So, data hashing 101. When we are hashing data, we are using a one-way mathematical algorithm, like we see on the picture right here. So we have some text or file, it could be anything, then we run it through our hashing algorithm, and then we get some hashed text out of it. So the idea behind this hashed value is that it is unique based on the content of this file or text that we have right here. So if we change a single letter or byte in this file, the hash value will be completely different. And that is the unique thing about this hashing. And when we get into what we're using it to, you'll understand why this is such an unique way. But the important fact is that these algorithms are one-way mathematical algorithms, meaning that you cannot take a hashed value and run it through the algorithm again and then get your original text or file out of it. That is not possible. So it is one way, and that is important to remember, because by having this one way algorithm that generate a unique value based on the content that you are giving it, you really have like a fingerprint of that particular file. So for example, your fingerprints on your own hands uniquely identifies you as a person, and it is the same for hashing. The hashed value identifies this file or text uniquely. Of course, there are some algorithms that have duplicates, meaning that some very rare cases that we are seeing that two files can get the same hash values, but we are slowly shifting away from these and using new algorithms that these duplicates are very rare or near to impossible. And we're using this when we are verifying files and in our public key infrastructure, because for file verification it is important for us that we can verify that a given file is what it is expected to be. So for example, when you download a file from a website, you sometimes will see that it has a MD5 hash underneath or somewhere in the browser, and that is because you can use that hash value to, after you have downloaded the file on your machine, you can run it to a MD5 algorithm as well, and if you get the same hash value, you know that no one have tampered with this file on the way, meaning that the file has gotten completely from the server that have this website and to your computer, and there is not a man in the middle who has switched the file around so that you get some malicious files on your computer. And we are also using it for passwords, because a secure system should never store passwords directly in the database. So let's see how that works. So password hashing is seen on this picture right here. So we normally know this login form type where we have a username and we have a password. So what is happening is that Henry is logging in with his username of Henry, then he is entering his password, which he has defined himself. Then our application will take his password, run it through a hashing algorithm, and then it will get a hashed value out of this password, and then they will be storing the hash value in the database instead. This means that only his password are able to generate this exact hash that we saved for this user. So if a hacker gets access to this database, let's say the entire database got hacked, they will only have the hashed value, meaning that they cannot read the password in plain text. Because if Henry used this password in multiple places and his password were in plain text, they basically had access to all other accounts that he used this on. Of course, we see similar problem if every website used the same hashing algorithm, because then the password will get the same hash value, and that is why we also have a salt value attached to this hashing of a password, but that is for another lecture. The important part here is that you understand that we can use it for password storing these hash values, and the fact that we can't generate them the other way around, we have no way of getting his original password. This also means that the developers and owners of this system don't know his passwords as well, because if they look up in their database, all they see is this hashed value, and they can't take this hashed value and try to use it as password, because then the hashed value will get through the hashing algorithm and again get another hash, and then it won't match this one. So they can see his hash value but not his actual password if this is implemented in the right way.